All right, this is a video on point-slope form of a linear equation, and in this video I have a challenge and a real-world connection problem for you. I encourage you to pause this video, try these on your own, and then check back in and see how you did. So first one on the left, a line goes through those couple points, -2, 1, and 3, -5. Determine the point-slope form for this line twice, so we have double work to do using each point, okay? And then convert each point-slope equation into a slope-intercept form. What do you notice? Why does this happen? Okay, so let's do it. Let's use our first point first. We need to find a slope first. So m is the difference in the y's divided by the difference in the x's. That's 6 over -5, I believe. Let me double check that. Looks good. So -6/5 is our slope. So let's find our point slope form first using the first point. So y minus y1 equals -6/5 times x minus x1. And let's just find slope-intercept form for that, mx plus b form for that before we use the second point. Okay, so just to be clear, this color coordinated, the first point in yellow is what I'm working with right now. We're finding slope-intercept form. Y minus y1 equals -6/5 x minus 12/5. Let's add 1 to both sides. Y equals -6/5 x minus 7/5. I think I did that correctly. These double negatives cancel out, so that's why we have a -12/5. And then we add 1 to it, so we're adding 5/5 to it, so that looks okay. All right, let's do our second one. Number 2, and we're doing this one in red. So y minus our y value equals, it's the same slope, -6/5 times x minus our x value. So just to color coordinate, that's our red equation there. Let's get this into a nicer point slope form. Y plus 5 equals -6/5 times x minus 3. And now we can convert to slope-intercept form. So let's distribute the -6/5 plus 18/5, and let's subtract, and I'm going to get common denominators right away. Let's subtract 25/5 from both sides. Okay, so these guys cancel. And we get y is equal to -6/5 x minus, looks like 7/5 again. Okay, so that's the solution to that one, and I hope you can see that we got the same slope-intercept form. Why does this happen? Because it's the same line, right? So we would want there to be the same slope-intercept form. But another reason why it happens is as we move over in x from x equaling, let's see here, -2, this was a -2 to begin with, over to x equaling a 3, our slope adjusted things so that we would have a corresponding movement in y. And so we would end up with the same equation overall. Okay, but really it's just the same line, that's why. Okay, next one, this Desmos connection, type the following into Desmos. Y minus b equals 2 times x minus a. And also type a and b into Desmos and add some sliders. So we're trying to find the slope of the line, what happens as you drag the sliders, and you get the same results with different slopes. So I'm going to go over to Desmos right now on my screen. Unfortunately, my cursor doesn't really show up very well on Desmos, so I'll just try to verbally explain to you what's going on. And I want to make sure I remember the questions though. Slope of the line, what happens is you drag the sliders and you get the same results with different slopes. Okay, so let's go type this in. So y minus b equals, was it 2 times x minus a. Okay, so let's add some sliders. So it looks like A and B, or let's also type in the actual coordinates of the point A's, of the points of the point A comma B. Okay. And we could label that right there. Cool. So let's drag things around. Okay. So I think what you're seeing is that the slope of this line is always stayed locked in at 2. The slope of the line doesn't change. But what we're doing is we're just changing the coordinates of the point that we're using in our point slope form. Okay, so here we happen to be using 4.9 comma 3.7. That's the slope that's going into the equation. We could even write this out right here. Y minus 3.7 equals 2, and then parentheses x minus 4.9. Okay, so the, x minus 4.9. So you can see the lines overlap. Okay, as I get rid of the red one or the black one, you can see they're the same line. Okay, so, but the sliders just allow us to kind of visually see that we're just using the sliders to pick the point that we're using for point slope form. All right, another question, does this work for other slopes? Yeah, it totally should. Let's confirm that. Let's put in a different slope of, I don't know, negative 5.5, who knows? And we can do the sliders. And so now we just have a different sloped line, but we still have the line is locked through the point that we have selected for point slope form. So nice, we did it, and that is a good place to stop.